Hello everybody, it's Mike here at Game from Scratch, and welcome back to our ongoing Godot 3 tutorial series. And today we're going to be talking about GDScript programming. Now once again, before I jump in completely, I do want to remind you, I am also doing a book version of this that is either available for purchase down below, will be available soon, or if you're a patron backer, sample chapters are being made available as I write them. So basically any work in progress chapter I publish is available there first. And it's pretty much one-to-one with this video series. So if you want a text-based version of everything we're covering here, be sure to check that out. Also, I am linking to gamefromscratch.com, which has all the source code examples that we use in a given chapter, all available there. So if you want access to just the source code of what we're dealing with, do be sure to check out that link as well. All right, without further ado, let's jump right in. What we're going to try and do today is cover how to use GDScript. GDScript is the built-in scripting language for the Godot game engine, probably the primary way the majority of people do their Godot programming. It's heavily inspired by Python. It's very simple and straightforward to learn. And one thing I'm going to assume coming into this video is that you have some programming experience. I don't care what language it is, but you need to understand the concept of what a variable is, what a loop is, what an if statement is, that kind of thing. Things that are universal to all different programming languages. And if you don't, actually I recommend a Lua-based, oddly enough, series I did back in the past, which teaches you programming from the very beginning, way beyond the scope of what I want to cover today, or this is going to be a 5-hour long video. So if you haven't got some previous programming experience, do be sure to check out another source before jumping in here. Okay, so what we are going to do is cover the specifics of GDScript itself. I'm going to start with actually creating a script. Now, if you've been following the series as we go, you probably already have seen me create some scripts. We're kind of got into a chicken and egg scenario. You need to know how to program in order to be able to do anything in Godot, but in order to do anything in Godot, you need to know how to create nodes. I had to pick one first, and I went with nodes. So we've already done a little bit of programming. Just push that out of your mind, and we're going to start from scratch. So here you see a blank empty scene. I'm going to go ahead and add a root node to it of type node. And yeah, that'll work. We'll go ahead and save our scene as scene 1, like so. And we shall just go ahead and run it so that it's set. Like so. So your standard setup. All right, we're good to go. Now we're going to go ahead and create our first scene. To create our first script. To create a GDScript is pretty straightforward and simple. Just basically select the node in your hierarchy you want the scene to be attached to, and the majority of the time GDScripts are going to be attached directly to nodes. They don't have to be, and I'll show you how to create a standalone script, but again, 9 times out of 10, your logic is going to be attached directly to a node like we're doing here. So right-click the node, go down and select Attach Script. And you'll notice here you've got a couple different options. Now, Godot has a number of different ways you can program it. You can use C#, which is currently actively under development, Visual Script, a visual programming language I will cover later on, as well as Native Script, which I will also cover later on. But for the majority of examples in this tutorial series, we're going to be using GDScript, and that's what we're looking at today. Now, you'll notice it automatically picked up what type it inherited from, in which case it's coming from a node, and that's going to be important in a second, as you will see. Template, really, you just decide if you want comments or not in your example. And here, what we're going to do is go ahead and name it. I'm fine with scene1.gd, but this is where you would name your script. Also, if you wanted to put your script into a subfolder, such as script, you could go ahead and add that here and put them in a subdirectory. So go ahead and create it, and you will see immediately that the script is available over here. Now, to actually open the script, just double-click it in the file system, and you'll see it opens up here. And you'll notice that this editor is actually available across the top of these tabs. So we've got your 2D editor, your 3D editor, and script. You can switch between those using the function keys, so F2, F3. So F3 brings us in here. Now F4 doesn't. Instead, it brings up and searches help, which is important and useful. And those are actually the same as coming up here and clicking search help. This is where you do the majority of your code editing. Remember earlier where it asked what node it derived from? Well, that's important. That's where it comes up with right here, this extend node. And this node class is pretty much the base class of everything in a hierarchy of nodes. So there's object-oriented programming going on behind the scenes. There's inheritance between nodes, one-to-one inheritance, so every node can have one parent. And you'll notice if you come in here and look up classes, you get a list of all the available nodes, starting from the root level node of all things, or the root level class of everything is the object. But what we're dealing with here is node. Clicking that will bring it up in the online docs, as you can see right here. And you can see what it inherits from and what inherits it. And most importantly, you can see what methods are available for it. And node is very, very important because this is essentially where your game loop occurs. And it's these functions right here that are absolutely critical. So you see here this on enter tree, on exit tree, input, physics process, process ready, unhandled input, unhandled key input. Well, those are the hooks back into your code. Basically, every single game ever made has a game engine of some sort. It looks vaguely like this. So when a game is run, it starts, it's initialized, the game loop is created, and this is a simplified version by all means, but basically you start your game, all the stuff you need to load your game is allocated, game loop is created, this is basically the thing that runs while your game runs, and what it does is loops over and over again, that's the name game loop, and it does things such as pulls the user for input, updates the graphics, updates the world, updates the physics. So you see get input, update physics, update world, render, and then repeat and repeat, repeat. So basically, if you say press the right arrow, it might do apply physics to move your character to the right a little bit, which would then cause your character to move in the world, and then your graphics would update, and then you do it again, 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 until you get a command to say quit this game. Now, a lot of times this is built into different levels, and then you don't actually quit the game, you quit out a level, go to another level, etc. But this is the basic idea behind a game loop. Now, once your game loop is done running, what you'll often then do is go into a cleanup phase, get rid of all your junk, be a good neighbor, tidy up after yourself, and then your game exits. So at the top level core, this is what a game loop looks like. This is managed by the game engine itself. Now what you've got here, when you go back to Godot, these are the different points in the game loop. So this is enter tree. It's basically when your node has just been inherited or created and added to the scene. Now there's a couple of things that are important to understand here. We'll get back to them in a second. Exit tree is the same thing when you're removed from the tree. Think of the tree like the level or the scene. Then we got input. This is where you pull for user input or respond to input events. In this particular case, this is actually called when the user does input. So if I press the W key, the input function is fired if you tell it to listen for it. We'll cover that in more detail later on. Again, you see here your physics. This is called when the physics are being updated. You may not actually have to do anything here, but if you want to override that behavior, that's where you'd call this. This process is normally called update in other game engines. I'm not sure why they wanted the name process, but basically this is where the logic of your node goes. So if you have a programmatically controlled node, you would handle it in process. Ready is when, again, it's like enter tree. I will explain the difference in a second. And these two you actually rarely use, so we won't cover them in this specific instance. Now, you may be wondering why there's enter tree and there is ready. And the difference here is basically enter tree, it's called after its parent's own enter tree, and it will only be called once each time a level is loaded. While ready is called after enter tree. So basically enter tree will be called before ready will be called. But ready will not be called until after all the children have been ready. So basically, if you then depend on a whole bunch of child nodes to be up and running and ready in the code, you handle it in ready, whereas enter tree will be called before all your children are initialized. So that's what the difference is between those two things. It's kind of like an order of operations. If you have a dependency on some child node of your node being ready, you use ready. Otherwise, you can use enter tree. And keep in mind, enter tree happens earlier in the life cycle than ready does. And most times, you're actually going to be able to get away with using one or the other, but there is a reason why both exist. Okay, and before we move on, I do just want to clarify that these are available to every single node-derived class. So we're going to be using a lot of times, like for example, spatial, if you're working in 3D, has all of these specific methods and functions available for it, but it also has, so these are all the members and public methods that are specific to spatial, but remember, spatial inherits from node. So it gets all of this functionality from node, and node in turn inherits from object, which then in turn gets all of these classes from object. So you do inherit all of the abilities of your parent class. So do be aware of that. But almost anything that's drawn, well, actually everything that is drawn on the display or visible on screen will ultimately inherit it from Node. So if it is in here, anywhere, so any of this stuff or the derived stuff below it, they are all node based. So you can see the inheritance here. So animated sprite is a node 2D, which is a canvas item, which is a node, for example. So they get all of their inherited functionality. One of those important things to point out. Now let's take a quick look at some scripting. Let's head on back over here to our code. You'll notice over here there's a hot list of most recently used documents. So here we've got object that we opened up, spatial. These are the documents or the things that we recently jumped through for documentation, but our code is also here too. So if you've got multiple code files available, you can jump through them here. Now I also mentioned earlier, you can actually have standalone GD files. So your GDScript files don't have to be attached to the node. If you want to go ahead and create one yourself, you can also do it this way. So file, and then new, and then you just save it as a GDScript, and then you'll have another file open. And again, you can tab through them this way. Now, the cool thing here you'll also notice is when I have it open, I have a quick list of functions available right here. So you see we implement one function called ready. So you can quickly jump to it using this little guy here. So if we had, say, this guy was enabled, oops, like so, then you will now see it. So you could quickly jump between different functions. Very handy way to work. But let's get rid of that guy completely, and we'll take a look at this class. We'll get rid of all of this gibberish. That is, remember earlier when we picked the templates, it can be comments or no comments. If you don't want all that code to be in part of your template, you turn comments off and it won't be generated. But let's talk about that for a second. This is a comment in GDScript. Now, a comment basically is for you or for someone maintaining your code. It has no effect on performance. It has no effect on anything. It is actually stripped out when this is converted into a machine readable format. It is just there for you. And basically, a comment works by the number sign. Anything found after the pound sign is interpreted as a comment. And coincidentally, we can do as many pound signs as we wish. Now, one thing to be aware of, in other languages, there are things called multi-line comments. So I could do things in C++ like do this, and then at the end do this, the opposite symbol, and everything in between will be a comment. That does not work in GDScript. You only have a single line commenting system available. You can, however, comment multiple lines at once. So for example, if I have all these lines of code selected like this, I can hit Control K and it will turn them all into comments, and then I can hit Control K again to turn them back. So multi-line comments aren't a huge thing that are missing, but it's one of those things you might be aware of or might miss from other languages. Now, as we mentioned earlier on, ready is the thing that's called when your node is ready and all of its children are ready. So this is basically where you would normally put your one-time initialization logic for your node-derived object. And this is, where you do your setup. So if you were an NPC and you wanted to set its name and health, initial location, etc., it's often common to do it in the ready function. And let's take a look at some very simple code here. You'll notice, first off, we have this extends. Basically, this is where the inheritance system works. This is what tells this script file what kind of class the parent is. So it knows that everything that follows is a node-derived object. And then func declares a function, and you'll notice something going on here. If you come from a C++ background or JavaScript or Java or pretty much almost every modern language, this might be a little strange to you because what this is, again, it's taken from Python. It is a white space-based language, and that means new lines have an importance and indentation has an importance. So you can see right here there's an indentation marker. It might be a little hard to see from, see if I can zoom that in enough that you can see it. All right, right here, this guy right here is basically a sign that there's been an indentation. We can do tab and shift tab to move things back and forth. That is what you would use in place of a squiggly bracket in another language. Basically, that says that the body of this is in that level of indentation. So I'll show you what I mean by doing a bit more of an example. Now, pass is basically just an empty line of code. You can't have, see, we just got an error here because you can't have a function and then here it goes, this is what the contents of the function is, and then nothing follows. So obviously you're gonna get an error basically saying indented block expected. So that's where pass comes in. It's basically, that's a way of saying this is an empty function. But instead, inside of ready, let's do a couple of things. First, I'm gonna show you a variable. We'll get back to variables in a second, but I'm gonna show you one in usage. 0 to 9 equals an array. Now you'll notice as I'm typing, we're getting code completion. There is full autocomplete and syntax highlighting in this editor. There's also debugging, which we will cover a little bit later. So this is declaring a variable. Again, we'll talk about variables in a second, so I'm not going to get into too much detail on that one. So what I want to now do is for I in range 10. This is the same as for int I equals 0, I less than 10, I plus plus in another language. Like so. And again, the indentation is important. So the body of this function is this right here, but the body of this for statement is what's indented here. And again, you can see another indentation marker going on. And what we'll go ahead and do, oh, and one other thing to show you. There's this little guy right up here, which might be handy right now, that enables you to expand and shrink the middle window to take up as much room as you want. All right, so there is a for loop declared, and inside of this for loop, we're just going to add to our array. Oh. Like so. So what this does basically is from 0 to 10, so in range, so this is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Another important concept here is GDScript is 0-based, unlike Lua, which is 1-based. What we're just basically doing here is looping from the number 0 through 9 and adding it to the end of our array. And then notice here that I'm tabbing back. So this is the body. This tabbed in bit is the body of this for loop. So if, for example, I'd done this line of code would still be inside of this scope or this body. But what we now want to do is actually end our loop. So what I'm going to do is tab back here. Now what you might want to do is an enter. That has no effect. So blank vertical space is completely fine. But you'll notice we're still tabbed in to func's, this func ready indentation level. So this is going to run after this for loop is finished as part of this scope. And what I will now do is just basically print out 0, 2. And as again, you're seeing we get the code completion like so. And so our script is attached. We should be able to run our code. GDScript just ran. Now I'm going to zoom out of here so you can actually see the debug window. And there you see in the output 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is how scope or basically scope or bodies work inside of the GDScript language. It takes a little bit to get used to the white space based language if you come from a squirrely bracket race language, but it is it's pretty straightforward once you get to do it. It kind of, you have the whole holy wars in the sea world of where you put the close and open brackets. Well, the nice thing is in this particular case, you don't have that. Now, another thing you may have noticed if you come from one of those language backgrounds is there's no line terminations going on here. So for example, I don't have to put or close a line using a semicolon like you do in C, Java, etc. But however, you can. So if you want to put two lines of code on the same line, like so, you can use the semicolons to separate them, basically to say that this line of code ends here and then this one starts. So saying this is exactly the same as saying this. So semicolons are completely optional, but if you want to put two lines of code on the same line for some reason, which you probably don't want to do because it's a pretty bad coding habit, but if you want to, you can do it using that semicolon operator. Okay, so now let's go on back to our types talk. So I'm going to get rid of all of this stuff. And instead, let's look at some types. So here is a perfectly valid way of declaring a variable in GDScript. Basically, what we've just basically said is the variable, so create a variable, name it A, give it the value of 1. Now, an important thing to realize is, once again, scope comes into effect. So this variable was declared within the scope of this function. So as soon as we get out of this function, A no longer exists. It's gone. So that's a local variable here. If we wanted it to last and be available across the entire script, we would instead put it here. Okay, so that puts it in the scope of the entire script. Important to realize that's one, and that is another area where scope is important to understand. But what exactly is this var? Well, it infers its type from the type you assign it. So in that first example, we declared it as an array, as an empty array. So it knew, oh, okay, this var is an array. In this particular case, we're passing in a number. And a number could be a couple things. It could be an integer, it could be a floating point number, it could even be a string potentially. And what's happening here is Godot is inferring the type. It's guessing what this is. It's called duck type. Now, duck typing comes from the expression, if it looks like a duck, quacks like a duck, it sounds like a duck, it's a duck. It's using the basic logic here. It's basically, as a variable is first used and first declared, it infers its type by what you assign it. And if you want to be more specific, then you actually have to use the type directly to declare what you want it to be. This way, if it for some reason gets it wrong or you want to change it up, this will implicitly tell the Godot engine how you want this to go. But for the most part, it's going to get it through type inference. So in this case, A is an int, B is a float or floating point number, C here will be a string, D here is a vector. There are a number of built-in types beyond, so you've got your basic types, but you've also got a number of built-in types that were built. They're high-performance C++ code behind the scenes. Vector2 is one such thing. So you've got higher-level stuff like the classes and objects you create in GDScript, but a lot of these little lower-level types are going to have very good performance. So be aware that that is a thing here. Oh, not a car, a var. And then finally, var e equals, and I'm going to show you how, again, type inference works going on here. So we're going to create a string out of the value of b, which was a float, and then we're going to add c, which is another string, to it. So this is duck typing in action. And let's print out the results of e. And you will see e is 2.13, like so. And we'll close that down. So what it's done basically is it turned 2.1, and then so it's figured out that 2.1 with this conversion right here is a string, and we add another string to it. So this add operator is figuring out on the fly based on, okay, I'm adding a string to a string. But what would have happened otherwise here? Well, this is where, again, the duck typing thing comes in, is once it's assumed something is something, it goes with that. So if I hadn't done this implicit cast here, so if I hadn't turned b into a string, so what I'm doing here instead is I went with b plus c here, and keeping in mind b is a floating point number, c is a string. Well, you can't add a floating point number to a string without a conversion. You need to either turn the string somehow into a number or turn the number into a string, which is a heck of a lot easier to do. And what we did the first time when we had put the string declaration here. So when we don't do that, so what we're doing here again is adding a number to a string, what is going to happen is kaboom. So basically what it's telling you is you can't turn a float and a string together. So at runtime, if your types fail, you're going to know about it. And sometimes you're going to have to massage your data to make it work. But for the most part, the type inference system works really well. It's handy. And it actually is, it a lot of times actually keeps you from having to know what types you're dealing with. You don't have to go back to the documentation to figure things out. But you will run into issues every once in a while that you have to work around, like what we just saw in that example. And do recall, once again, that everything in here is in this particular scope. So let's say, for example, I came up here and I wanted to have global variables, such as, I'll introduce a new concept to you. This const pi, which is not a var, it's a const. I'll explain that in a second. And another variable called radius. These are now available across the entire script. So I could go ahead and have many different functions, and these will still be available. Now, do be aware they're only available locally in this script unless you do something specific to export them out. Actually, they'll ignore that last comment. I was actually technically wrong. So this particular case, we could do something like this: var area equals pi times radius, and then we could do a print area, and this would print out 3.28 or 6.28 for this example. So this is how you declare variables across scope. Now this, again, this area variable dies at this point. It will no longer be available after this, but pi and radius still will be because of the scoping rules. So there's where scoping is a very important concept to understand. Now, this const, what basically that says is that once this variable has a value, that value cannot change. which is useful in situations like this where you do not want the variable to change. So if I came down here and I said I want to reinvent the laws of the universe and change pi to equal 4 instead of 3 point, you're going to go ahead and get a very big error when I go ahead and run that code. Why did you allow me to run that code? All right, that's stupid. All right, consts are apparently not working how I'm expecting them to do, because that should have thrown me an error. All right, so anyways, we're going to continue on from that. I'm going to have to look into a little bit why, because that is not how const should be behaving. Now, I also mentioned earlier on that sometimes you're going to want to be able to make variables available to the editor or outside. And in that particular case, how do we do that? Well, we can take this same example minus our weirdly mutable const. So we got this guy right here. What we could do is go ahead and make this variable, this radius variable, available to the tooling instead. And this is very easily done because we just add export to it. And now we're going back over to the editor here and select our node. You'll notice down here all of a sudden there is script variables. So right here we can change that to 3, and then when that particular code is actually run, it would it's running on ready. So in this case it's already run, but we can change that variable. So if we used it later on in a different function or whatever, changing it in the editor will change it over there. Also, when I go ahead and run this, so let me do that right now. So here, let me change radius to 10. And I run that, you will see instead of 3.14, we're getting 31.4. So that is the ability to export your variables out to the editor very simply. Now, one thing you will find on occasion is that you want to tell it what kind of variable it is, which is also easily done. So you can actually come here and say, let's say we need to hook up a texture object to this guy. We can also do it like that, and then you see here it figured out what it is, and on top of that it also figured out how to use and load the appropriate editor. So if your node requires an image or something, but you need it to be set in the editor, or you want to make it editable in the editor, all you need to do is do this export. But in this particular case, we're going one step further and telling the export token that what we're exporting here is a texture, and they can use that logic to automatically update the appropriate editor. It makes integration with the editor very straightforward, very simple process. So it's quite a cool bit of functionality in the Godot editor. And one of the things, if you go through my channel, I've actually already done a video on creating tools using exactly this functionality. It's a very powerful thing that Godot can do here. And now let's move on to the two main container types. We've actually already saw one of them in action, and that was the array class. Let me get rid of all this code. Oops, I've got the wrong thing highlighted. So let's get rid of you, all gone. And you, we saw it earlier on when I used an array. It's pretty straightforward class. It's where you store a collection of objects. So you can do it like var my array equals, and you can do an empty array using either, like we saw earlier, like so, or you can use the array operator like that, or we can actually define it, and we can put a collection of just put anything in here. So we can do 2, 3, 4, like that, and you will see it prints at 1, 2, 3, 4. And really, you can just think of an array like a list, or yeah, pretty much it's a list. And in the case of GDScript, it doesn't even really matter what the contents are. So you'll see. So this actually is a bad example. I should have used the full written verb, but we've got a int, a string, a float, and another int all together in the single array. So, and then we can go ahead and add to set array, as we saw earlier, using the append, like so. And arrays are a very common class to work with. It's, you know, you're dealing with lists of data all the time. Oh, I actually removed the print statement, but this would print the word Bob at the very end. And as you saw earlier on, you can use the .range function, so we can go do the same thing for using arrays. So basically you're saying this loop will now loop through each individual value in this array, assign it to the temporary variable I, which we can then, for example, go here and print it out. So this is one of the easiest ways to navigate through an array. And off you go. like so. Don't worry if I'm hitting you with a lot of stuff here. Just come on back, refer to it as you need. This is obviously a large subject of matter to get through, and I'm trying to fly through it a bit because we still got quite a ways to go. But that is the basic array type. If you've worked with any other programming language, you're probably already familiar with arrays and the navigating arrays. And the next one up is dictionaries. Now, dictionaries are like tables or databases almost. It's a way of storing information, kind of arbitrary information using key value pairs. And you can do an empty one using a different set of brackets, like so. That creates an empty dictionary, so then we could go ahead and start filling it out. So monster.name equals orc. And then we can access that value. So again, here what you've got is you've added, this is the key, or the way you identify the variable, and this is the value at that key. And we can go ahead and access it using like so. And you'll see down here, it prints out orc. So this is a very, very, very powerful way of storing information. You can store multiple pieces of different disparate pieces of information in here, and pretty straightforward way of storing data as well. So let's look at a slightly more complicated or inline declaration. And this is cool because you can actually store your data basically as script. So let's go ahead, and now the spacing I'm using here doesn't matter. This is just so that I can see it from my end. So what we're doing here is we're entering a new, and what we're essentially doing here is creating a dictionary inside of our dictionary, and our dictionary's name is orc. And it has the value of a dictionary. So again, you declare our dictionary inline using these brace brackets. So what we're saying is this dictionary contains an entry, which is another dictionary named orc. And this is how you basically create a database type layout. And we're going to give some information for our orc. So it's got a value with the key of HP and the value of 42. So it's got 42 hit points, alignment like so, and the alignment of chaotic neutral like so, and closed off that bracket. That is the end of our first embedded dictionary like so. And if we wanted to keep adding data, let's create another table. This one is called elf like so, and it is a table. Now you may notice that I am indenting and not indenting all at once. You can do shift plus tab to indent a line back, and then tab obviously to indent it back forward. And we'll give the elf obviously less hit points, and goody goody. Like so. So basically we just created a little database of monsters. We can keep nesting dictionaries inside of dictionaries inside of dictionaries, but some pretty powerful stuff going on here. So that is our monster declared. Now you'll notice I didn't indent it. Oh no, I did indent it. I just have some weird code formatting going on. So let me zoom this way back down so we can all see. So yeah, all inside. Monster is inside of ready scope. So in theory, we should now be able to access this guy. So let's go ahead and print. And accessing it, so we called the thing monsters, like so. And I want to go elf HP. So you see how I'm accessing the individual values within that dictionary. And then we come down here and we get an error because monsters is not defined because, all right, you know what, not monsters makes more sense than monster. Variable names are case sensitive, and obviously you have to spell them correctly. All right, stop, save, run. And there you see, we printed out the elf's hit points at 28. So those are the two major ways you're going to store data inside of GDScript. You're going to probably either be using straight out normal variables like ints, floats, strings, etc., or their built-in types such as vector2, which is specialized data, vector3. There's tons of built-in data as well. Or you're going to go about this mechanism we just showed you right here. You're using either an array or a dictionary, probably the two most common types. Now we're going to look at actually dealing with some data using if statements or conditionals. The most common one, again, I just said, is the if statement. So let's use the data we just populated, and we'll work on our elf here. So if monsters.elf.hp is less than 5. So this is basically a conditional. We're saying if this is true, then run the code that follows within the block. And all we're going to do is say elf needs food. Save that, and we'll run it, and absolutely nothing is going to happen. Like so, because our elf's hit points are at 28. So let's sit here and go monsters.elf.hp equal 4. Now suddenly this will be true, this condition will evaluate, and the block of code inside of it will in fact trigger. And you'll see elf needs food. All right, so there you go. That is an if statement. Now what you'll often have is multiple conditions. So in this particular case, it was pretty straightforward because we had the elf here, you know, the one condition either was less than 5 or it was more, run this particular case. And now what we're going to do is expand this out a bit. So what we're going to do is elif. Now an elif needs an if at the same level of scope, like you can see right here. And basically this is just our way of saying, okay, if that first condition wasn't true, well, what about this one? And elif is short for else if. It's another if condition, and this will only evaluate after this one. So if this was already true, you'll never get to this point. But if this was false, then it'll check to see if this condition is true and continue on down. And now we'll say if monster.elf.hp is less than 10, we'll do elf wouldn't mind some food. Sorry, I'm trying to get it so that it's all on screen, but you can also easily read it. There we go. Pretty good compromise. And then finally, you can have an else. And what this is going to be is if none of the above conditions were true, then this will fire. So this will always be true if you get to it. But if this was true or this was true, you will never get to this point. And in this case, we'll go else.print. Actually, I'll stay consistent with my text version. Elf might have an eating problem. All right. So we run this. In this point in time, elf's hit points will be 28. So obviously, this will be the end result. Why are you angry at me, editor? If, else, if, else. I made an error here. Monsters.elf.hp. God, I can't stop doing that. Okay. Go ahead and run this. Okay, why are you getting mad at me? 19, 22. Oh, I don't know why I threw that. Okay, another important thing to realize here is I went ahead and I made a stupid error on our code. So you can see right here, I don't know why, but there's a period behind HP, and that's going to cause the code to throw up. And you'll notice down here there is an error, and this error is very important because first off, it tells you what the issue is. And a lot of times, this is going to be very confusing. Basically, because I used this dot, it's expecting me to use, that's the member function variable. So basically dot, and then you access a member variable out of it. But in this case, I just did a stupid typo. So that's what this error message is saying here. It's expecting it to be, you know, blah, blah, blah. A lot of times when this doesn't make any sense, this is the important part. This first part right here is your line number. So you see right here, 19, 19. And then 22 is the token number. You know, a little bit less useful, but it tells you basically that this is the error, that it went wrong. And that is very useful for figuring out why you just screwed up. I don't know why it's giving me an issue on the scene. Oh, it's running. I don't know why it was running. All right, we'll save that and run it. And we run it, and then you'll notice the else condition is true here. But if we set the elf's hit points to say 8, then this would have been true. If we set it to 2, then this would have been true. So that's the basics of the if statement. Now we're going to move on to a very, very powerful alternative, but we're only going to kind of touch the edge of it because it does get, it's much more capable than what we're dealing with right now, and that is the match statement. Now, if you come from another programming language, match is called switch, and it's a lot like an if, else if, else if, else if block, and you say here is a value, do you match blah pattern, and I'll give you an exact example. Var value equals 6, and we're going to do a match on that. So match value. So basically we're saying here is the value, what matches this? And then you put in a bunch of conditions. So for example, if the value is 1, this is the code that we'll run. Oh. Like so. And then we could say if, and then here's where match gets very, very cool. We can also do things like if in this range of collections, like so, and then we can once again do this, and then like so. Now, what you also could potentially find, and I'll explain it in a second, is you can also have a catch-all. So we'll do here, for example, and it's just the underscore character. And it's basically saying it's the same sort of thing as before. As you're going through this, as soon as something is true, it goes on to the next level. So, or doesn't go on. So if it's 1, we're done. So we come in here, if the value is 1, it gets to this point, it prints out as 1, and then it stops evaluating. But if it wasn't, then it keeps doing the tests until it gets to the bottom. Well, this is a catch-all. So underscore basically says everything that comes in here will be true. So we'll go ahead and say something else. So if we go ahead and run this code, you will see, since value is set to 6, it will come down here and evaluate to it's 6. So what that's saying is, it went through all of these different evaluations, it came out and it checked in on this guy right here. Now I'm going to go ahead and change value to 4, and you're going to see it's going to come into this block instead. Like so, between 2 and 5. Finally, if I go here and I make it blargo poop, obviously it's not going to be any of those other values, so we instead are going to hit the catch-all, which brings us down into here, something else. So that is how a match works. Now, a match can also do things. There's special matches for dealing with dictionaries and special matches for dealing with arrays, but I'm not going to get into them in this particular example. But a match is a very powerful way of, checking for a variable for a number of different values. Now, one thing that might be very common to do is, as I said, as you're coming down here, once a condition is true, it no longer evaluates. So, for example, if this guy had the value of 6, then 6 will come true, and then it will just exit completely. Well, sometimes you'll still want it to go ahead and keep being tested. And what you can do in that particular case is just add the line continue. So this means, okay, even though you were true, I want you to keep running the rest of this tests. So what we'll see here is what happens is it's 6 and it's something else. So if you want to keep testing it, even though it's already been proven true once, throw the continue in at the test and it will go through the other tests as well. All right, so moving on, that is conditionals, variables, program flow. We covered most of the basics of what you need to know. You know how to add stuff. But one thing that is very common is basically wanting to deal with global variables. How do I make something available across all of my code? So for example, earlier on when I defined pi, I might want to build pi into global level code. How do I do this? Well, this is done using something called auto loads. And let's create one right now. So first off, go ahead here and create a new script. We're going to call it from GDScript. We'll inherit from node again. And we got to give it a valid name or path. And in this case, I'll call it actually, what did I call it that time? Game globals. Game globals. Like so. Name obviously didn't matter. And we'll get rid of all this junk because it's not actually going to be part of the game loop process. There's no ready call. There's no, well, I guess there is, but it's not a node traditionally that we're dealing with. I'm just using this to define a bunch of variables. So now that we have our global script created here, let's just put a couple of variables in here. Meaning of life equals 42 and var description equals this game is amazing. So these are variables that will be available across the entire lifestyle of your program. But since they're not attached to anything, how do we go about using them? Well, that is done via the auto load settings. So come up here to your project, go to project settings, and you'll notice across the top here, there's this tab called auto load. And all that's really saying is load and run this script when this project is loaded. So this stuff will all have been evaluated and will be available everywhere. So now what we need to do, now that we're in here, we can go here and pick our script. So we click the ... next to path, and we pick our global variables like so, and we just add them in. So now we have a new set of global variables. It's enabled. We can delete it this way. You can also set the order. So if you have multiple, the order that they're loaded in. And so if one of your auto loads depends on another auto load, you move it so that it comes after it in the order. Since we only have one, we're obviously not going to be moving it back and forth. And that is it. So now that script, as soon as this game is loaded, that script will have been loaded into memory. So if we head on back over here to our scene, for example, we could instead say here, let's say, yeah, we'll twist off this guy. So instead of matching off value, we will use our globally declared variables. So I'm going to say global, and you'll notice here we got nice code completion going on. So game.globals and meaning of life. So that is how simple it is to get a global variable. And let's just change this out and go. And they can be used that simply. So making variables available across the entirety of your application is quite simple. And since it's a singleton, it will only be loaded once. You don't have to worry about there being multiple calls of this. It will only happen that one time. So pretty cool stuff all told. I did a quick example in the book of showing it all together. I don't know if I'm pretty pressed on time here. I'm already at the 45-minute mark. So I'm going to do this as a quick copy and paste job. So what I'm going to do is just a script that uses a lot of what we just covered all at once. And that is, I'm going to create a new node here. We will call it, it's a node 2D because it's actually going to draw in the screen like so. And then we'll attach the script like we did earlier on. So this is how easily you attach the script. I'm fine with calling it node2d.gd here. And in this case, I'm just going to do a quick paste. Oh, it killed all my formatting. You bugger, you. All right, so that's kind of ugly. Just a second. Yeah, this is gonna be too much of a mess. 1 second, please. Okay, here we are with actual proper formatting. Now, a couple things to notice here. First off, we inherited from node 2D instead of node, and you'll notice the extends is completely different. So this is, again, what tells this script what its base or parent class is. Use a couple examples here. This is exporting a variable out called number of boxes. So if we go here, select our guy, you will notice over here we have the option for number of boxes. We also exported out a variable for the dimensions. You see it's a normal straight old dictionary. It would normally make sense to make this a vector too, but I wanted to demonstrate creating a dictionary. So here's a dictionary with two values. One is width, one is height. That is also exported out. So if you select the node here, you will see there's a dictionary and the two different values you can set right there. Let's go back to our script. So here in our ready, we do a standard loop, basically. So this is the number of boxes. So there's 5 in this case. It'll loop through this code 5 times and execute this particular code. What we're basically doing is just randomly positioning them within the screen, these boxes that we're going to draw. And tell it to handle process. So that means that the update call is actually pretty meaningless, but this is what you would use to tell update to call. This is mostly here just to demonstrate the pass. So if you have a placeholder or an empty function, if I had removed this line of code, like so, or commented it out, and save that, you will see indentation block expected. You cannot, once again, have an empty line of code. So that is why that pass call is there. And this is basically here just for demonstration. We're not doing anything in update. Instead, what we're doing is overriding the draw function. And this is something I'll cover later on in 2D graphics. But all I want to do in this particular case is loop through all of our boxes. So you see here, you can loop through an array easily enough just using the in. So this is going to create a temporary variable called box for each variable in the box location, and then go ahead and draw something on screen in the color of red at the location of that box. Pretty straightforward, easy code. Let's go ahead and run this. and you will immediately see the results. And if we want, we can once again come back into it, and I can change this guy out to say 15 boxes, run it one more time, and you will see a great deal more boxes. Or I could come in here and change the dimensions. And we've got little boxes full of ticky-tacky, like so, all around the screen. So it's kind of a contrived example, but it does show you almost all of what we just covered put together into a bit of a more real-world example of what we're working with. It's also extremely commented, so when you do check out the source code for something to play around with, do be sure to check that example. I will link that below as soon as the homepage for that is up. And again, it is in the book, and if you're a patron backer, that chapter is currently available on the patron Dropbox and linked in the patron page. So that is a pretty much crash course of GDScript, just under an hour. There's a lot to cover there. I hope I didn't lose any of you. Let me know if you have any comments down below, but we are going to cover one last thing before we finish, and that is the debugger. And debugging is one of those skills, it's going to take me way too long to explain it, so hopefully you just accept my word that debugging is a very, 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 very important thing to understand. And let's show you actually how to go about debugging it. So here we've got this function ready. Remember, that's called when our code is initialized. And if we want to figure out what's going on in ready, what we can do is set something called a breakpoint. And all I did is I clicked over here in the margin, and this little red dot showed up. That's a breakpoint. So what happens is when the code runs, the debugger is going to sit there and go, oh, hey, breakpoint, and it will stop. And since this is actually on a loop that is going to run 5 times, or however many times we have defined over here, which I will set back to 5 because I don't want to go through this too many times. This loop will actually run over and over and over again until it's complete. And let me show you how this works. So let's go ahead and run it with that breakpoint set. Boom. So as soon as this ready code was run, so that here we are inside of ready, we hit the breakpoint, and it brought us down to the debugger tab down here. And there's a couple of really cool things going on. First off, you see over here local variables, so variables within the current scope. And then we've got various different member variables available, and you see even our globals. So you can see the value of them. In this case, it's an alias, so we drill into it to get more detail. So if I click down on object 95 blah 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 6, you'll notice over here we can get the detail, so we can actually see inside of what that object is. Same with self. Self is a special object that basically refers to the currently running object. In this case, it's that node 2 we inherited from. So if I click here on self and we click, you'll see all the different variable functions that are available for this particular object are available, and their values are over here. You can change them on the fly, tweak around. Just keep in mind any changes you make are lost as soon as you're done the current debugging. But if you want to try it with different values while it's running, you can do that. But also for simpler types, you can see the values are available right here. And for things like dictionary types, again, it expands and shows it over here in the inspector. Now what this allows you to do is run through your code. So this highlighted line that we see right here is our currently running line of code. So what we can do is using these 2 commands right here, we can jump into and over, or we can just say, okay, just keep going. And if I click that one, our code obviously just runs and keeps going. Or what that would normally do is keep going till the next breakpoint. So if I went ahead and while we were running here, I set another breakpoint and I say, okay, just keep going, it's just going to run till it hits that next breakpoint. Now, it should be on this, yeah, line 16. You can see right here. So we're currently on this line of code. And what's cool there is that means from before we were right here, and since then X and Y have been assigned a value. And now you'll see in the local scope what their actual values are. And as we continue to go through this loop, these will continue to update. And that can be done using this guy right here. So you see, we're passing through the loop. So I keeps changing, I is our index, and we just kind of use that to keep going down and through. Now you'll notice there's these 2 guys, step into and step over. The difference between these 2 is more or less step into, this guy right here, will jump into if there's more detail. So say for example, we had a function right here called myFunction, and we did a jump into it. What would instead do, instead of just evaluating it, would actually jump into the code for that. And then when that code was done, it would jump back out. Otherwise, this one just goes to the next line of code. So if you need more details, and the details are available, it will trace. So here you can see we're digging into our code by using this particular guy right here. So that is debugging in a nutshell. I believe the hotkeys are F10 and F11. I'm not going to touch either because that is also the hotkey for stop recording. But that is a very, very, very nutshell version of debugging in the Godot engine. Now, one other set of hotkeys to be aware of. You notice we've been using this guy to run our code. You can also run your code using the F5 hotkey. So hitting F5, it will go ahead and run it. So here you'll see we're in this code. F5 is also the same as continue. So you notice we have this breakpoint right here. So if I hit F5, we're just going to jump forward in time to, oh, is F5 not the same as continue? No, it's not. All right, so boom, jumps forward, and oh, it is. It's just kind of weird in the way it focuses. Then I'll jump forward to this in time. I click it again, it goes ahead and gets rid of it. Now, if we want to stop debugging completely, we can also press F8, and that's the same as going up here and pressing this stop guy right here, and done. Now, one thing I'm not covering right here, there's actually the ability to remotely debug. So you can debug on a Android device or a connected device, for example, over the network using the Godot engine. It's something I'll cover at a later point, way beyond what I wanted to get in here. And we're also broaching the 1 hour mark. So hopefully that wasn't too chaotic. That was an introduction to the GDScript language. As you saw here, it's a pretty powerful, pretty straightforward, pretty capable language. The whole idea behind it is that it's simple to learn, simple to use. But it's got these nice things like this export keyword that nicely, tightly integrates within the Godot editor. And as you saw, the debugger, you can nicely drill in and get more details of objects as they are running. So it's a very, it's a very user-friendly setup that they've got going on here. So that's all I'm going to cover for today. There's probably a few million things that I didn't cover. And if you do have specific questions, do let me know in the comments down below. But don't get overly hung up on understanding what you're doing here right now. I'm going to escalate the script in the example as I go. So everything we taught here is pretty much all you need to know to get going in the rest of this series. So don't worry about mastering the script yet. This is really one of those languages that you could quite easily learn as you use it. But if you do want to get more details, you're probably best off actually going to like a Python learning resources, learning the basics of Python, and 90% of it carries over. This is a very simplified version of the Python programming language. Obviously, you can't use Python code or libraries, etc. It's not Python, but it's very similar to Python. But in all honesty, what you just covered today in this particular chapter or video is probably enough for you to continue on in the series. And if I did lose you on something specific that I covered today, let me know and I will try to get it in the comments down below. All right, so that was GDScript 101 for Godot 3 game programming. Let me know what you thought of that, if you have any questions, comments, or otherwise, in the comments down below. And one last plug, if you do like Godot 3, the video tutorial, perhaps you'd love Godot 3, the book. If so, do be sure to check out my Patreon page. And you just help support the channel, help me keep doing this stuff, and it's really appreciated. But you guys just watching this is definitely appreciation for me. Your constant feedback is, it makes this easy to do. And so I hope you guys are really liking this series and liking the Godot 3 game engine. All right, that's it for now. I will talk to you all later. Goodbye.